Chapter 1 is about equations, so let's just first define what an equation is. An equation is a statement that two expressions are equal, and what we might call the answer to the equation, mathematically, we call a solution. And a solution is the value that makes the equation true. This is a phrase you might have heard before, inverse operations. What are inverse operations? There are two operations that undo each other, like addition is the opposite or inverse of subtraction. Hopefully you also know that multiplication is the inverse of division and vice versa. And we're going to look at some other inverse operations this year as well. Now, I need you to understand this is lesson 1.1, so things are going to get more complicated as we go through this unit and also as we go through this year. So I'm going to set you up with the foundation for how to solve an equation. While you might say to yourself, why are we doing all this? I can solve these simple equations in my head. I'm trying to build the procedure for the more complex ones when you won't be able to just solve it in your head, because there are going to be too many variables and really challenging numbers. So whether you like it or not, follow along with me and copy down everything that I ask you to copy down. Well, that was kind of weird. All right, let's look at example 1. We're going to solve and we're going to check our answer, which is like the instant answer key. We're going to take what we get for x, plug it into the equation, and make sure that we got it right. So you look at the equation. And the way that you solve any equation is you look at what operations you have. So I have subtraction, and then you say to yourself, what operation do I have? I have subtraction, so I'm going to undo it using addition. So what number is being subtracted? 3, so that's what number you're going to add to both sides. I'm going to add 3 to both sides. Some people like to put a little line down the equal sign just to kind of separate the two different parts. You can, or you don't have to. It's up to you. So these cancel out because they were inverses, and inverses undo each other. So the only thing that I have left on the left is x, and negative 5 plus 3 is negative 2. So that's the number that I'm going to say is my answer. And now I want to rewrite the equation and plug in negative 2. So if the original equation was x minus 3 equals negative 5, I want to check, is negative 2 the answer for x? So I plug that in for x, and then you actually do the calculation. Don't just like write it down and then go, yeah, it's right. Actually do it. What is negative 2 minus 3? And it is negative 5, so you get negative 5 on the left, you get negative 5 on the right. You can put a check mark, you can put a smiley face, you can put lightning bolt, whatever you want. Just show your reader that you got the same answer on both sides. Alright, example B is very similar, so I'd like you to pause the video and try it on your own, and when you are ready, click play and you will look at my work. Alright, so make sure that you have the inverse shown, make sure that you have your answer circled or boxed. And then also, because the directions told you to check, make sure you show a check. All right, let's move down to example 2. Now, example 2 is very similar, but we're using multiplication or division. So again, you say to yourself, self, what operation do I have? Well, if we're looking at letter A, the operation that I have is division. This is just a negative sign. It just represents a negative number. It's not an operation. It's not subtraction because there's nothing in front of it. So it's just a regular old negative sign. But the operation here is this fraction bar, which represents division. So you say, what is the opposite or inverse of division? And that's multiplication. So I'm going to show that I'm multiplying both sides by 5. Now what I want to do is use the parentheses to show I'm multiplying by 5. I don't want to use the x because that looks like another variable. Oh my gosh, 2 variables. So this 5 cancels out with that 5. So I have negative n, don't forget that, equals negative 15. And then you still have the negative sign. You might look at this and say, that it looks like the n is alone, but it's not, right? Because it's a negative 1n. Anytime there's no number in front of a variable, you put a 1. So negative 1 times n. So what I now have to do is I now have to divide both sides by negative 1 to get n equals positive 15. Now you could have done this all in one step if in the very beginning you wanted to. You could multiply by negative 5 on both sides, and then the negative and the 5 would have canceled out, but that's really up to you. Either way, you should end up with n equals 15, and since it tells us we have to check our answer, let's check. So I'm going to write negative 15 over 5 equals negative 3, and I obviously know my multiplication facts, so I know 15 divided by 5 is 3, so I get negative 3 equals negative 3. I'll do a little smiley face and move on to the next one. Now, you might look at letter B and start freaking out because you go, what the heck? There's a pi, and there's an x, and there's another pi over here, so what the heck do I do? But remember, pi is just a number, right? Even though it looks like a symbol, we are actually just representing this really long decimal number. So since pi is a number, x is our variable, so we have a number right next to a variable. So what operation does a number next to a variable mean? It means multiplication. So I'm going to inverse the pi by dividing both sides by pi, right? Just like over in letter A, I multiplied to get rid of the 5 because that was the number. I'm going to divide by pi because that's also the number. So I'm going to divide both sides by pi, and so the pi's cancel out on the left, and I have x equals, and just like they canceled out on the left, the pi's actually cancel out on the right as well. I know, crazy. So all I have is just x equals negative 2. So even though that equation looked super freaky in the very beginning, all it is just x is negative 2. So let's just check. So pi times negative 2, and I'm using the parentheses instead of the x because then it looks like another variable. So pi times negative 2 equals negative 2 pi. Obviously that's correct because they mean the exact same thing, right? The order doesn't matter. All right, I think we've done a few together, so why don't you try letter C on your own. Alright, so look at my work and look at your work. If anything is missing, please put it there. Remember, this is the foundation, so I want you to build the habits of solving equations correctly so you can have those habits already ingrained in you when we get to more advanced equations. Alright, now a lot of times with word problems, which is what we're going to look at in a moment, kids start freaking out because they say, I don't even know where to start. So, here are the 4 steps to doing a word problem. So the first thing that you have to do is obviously you have to understand the problem, right? So you have to know what the problem is, asking what information is there. Then you come up with a plan and you say, what equation am I going to write, or what sort of calculations am I going to do? So you come up with your plan of attack for the question. Then you obviously solve it. So you do whatever your plan is, and then you go back and you look at it and you say, does my answer make sense? Alright, so I'm going to scroll for a sec, and I want you to just read the little blurb at the top, and then I'll walk you through the 4 steps. Just read the little story about Usain Bolt. Alright, so the first thing that you do is you say, what do I know? I know the winning time, I know the distance of the race, and they're asking me to find the average speed. So those are like the main things coming out of the question. And then you say, do I have a formula that can help me, or do I have any sort of plan to help me get that answer? And you may or may not have already learned this formula. It's like a science-related formula, but if you don't know it already, here it is. You'll definitely use it later on, either this year or definitely in high school. And it's D equals RT. So you look at this formula, D equals RT, D stands for the distance, R stands for the rate or the speed, and T is the time. And if you go back up to what we know the distance and we know the time. So we can use this formula to find the rate or the speed. So I plug in what I know. I know that the distance is 200, so instead of D, I'm going to put 200, and that's going to be equal to R. I don't know the rate or the speed, so I'm just going to leave it as R, and that's going to be multiplied by the time, which is 19.32. All right, so now we solve. So I'm going to divide both sides by 19.32. Obviously, I need to have my calculator handy. So 200 divided by 19.32 is like 10.4-ish, I'm going to say. Oh, whoops, I didn't read. I have to read closely. It says in the nearest hundredth of a meter, so it's not 10.4. It is 10.35 because they want it to the nearest hundredth. So that's the answer I got, 10.35 meters per second. That's the abbreviation for it. And now we look back and we say, does this make sense? Well, if he's running about 10 meters per second and the total distance is 200, that would kind of be like 20 seconds. So I guess that kind of makes sense, right? Because they told us he was running at 19.32, which is pretty close to 20. All right, let's look at another problem-solving strategy. So this whole chart is a list of different ways that you can solve a problem. Now, you probably are skimming this and you say, what? Wait a second, my teacher always told me that you should never use guess and check. And in the real world, if you are really trying to figure out the answer to a problem, you can use guess and check to get the answer. But it's not going to show your teacher that you learned the skill, so it's really just going to show that you're a good guesser. So that's why teachers aren't really a super fan of guess and check, but all of these are different ways where you can kind of brainstorm ways to get a solution. So take a second and read the sentence, read the little story. All right, so the first thing that we do, just like the other question, is we look at our 4 steps, which is understand the problem. So we know the temperature before and after the temperature fell, and what they want us to know is, what they want us to figure out is how many degrees the temperature fell or went down. All right, so the plan that I'm going to show you is to write a verbal model, which is that very first one, because that's like an equation, but you could have used another one, and I'll show you another one in a moment. So the equation that I'm going to come up with is 54 minus what ends at negative 4. So 54 minus x equals negative 4. So now we solve, and how I'm going to solve this one is to first subtract 54, because the 54 is positive. Even though there's a minus sign over here, that doesn't apply to the 54, because then it would be over here if the 54 was subtracted or negative. So when there's no sign in front of a number, it's positive. So I'm going to subtract 54 on both sides, cross that out. And when I bring it down, I have to remember to bring it down as negative x. So negative x equals negative 58. And then just like in that earlier question, I'm going to divide both sides by negative 1. So I get x equals 58. So it went down 58 degrees. All right, now another way that you could do it is by doing like a number line, and that's how I'm going to kind of show you the look back, where you kind of say, does this answer make sense? So in the number line strategy, we start at 54 degrees, okay, and then it went down by some mystery amount, and it landed at negative 4. So if you think about the number line at all, right? So to go from 54 to 0 degrees, that would be a drop of 54 degrees, and then another 4 degrees would be 58 degrees. So it definitely makes sense. If you have any questions, write them down and ask me when you come to class.